Welcome to the 73rd lecture of Digital Electronics. In this lecture, we will be giving an introduction to code converters, and we will be dealing with two code converters in this lecture. That is an overview of this lecture. So coming into code converters. In digital circuits or in electronic circuits, we have different codes like 8421 code, BCD code, gray code, SS3 code, 5211 code, etc. Now, if you are getting, say for example, 8421 code, how you can convert it into BCD code? Or if BCD code is given, how you can find 8421 code? Or if gray code is given, how do you find the BCD code? Or if BCD code is given, how do you revert back to gray code? Okay. So we need to develop a logic circuit to convert between these codes. Okay. So you are having many type of codes, but I am not listing the entire list of codes which I am having. That is already done in module 1. But in this module, the main concentration is on how to convert between the codes and how to generate or formulation of a logic circuit. Formulation of a logic circuit for code conversion. Okay. So basically the aim is you are having a certain code here, say code 1. It can be 8421 code, BCD code, gray code, SS3 code, or 5211 code, or you can have any other, or you can have any other type of codes, and to be converted into some other code. Okay. So for example, if 8421 code is input, we can get BCD as output, or if 5211 as input, we will get SS3 as output. Okay. So this is basically a black box of code converter. Okay. Now coming into an example, here I am going to explain about binary to gray code converter. Binary to gray code converter. So obviously you are having a binary input. Okay. Binary input, say I am going for a 4-bit binary input. Let that binary input be A3, A2, A1, A0. This is the binary input I am having. Let the corresponding gray code be what? Be G3, G2, G1 and G0. 4-bit gray code. Now we need to find the relation, we need to know how to convert between these codes based on Boolean expressions. So how to convert? Here we can write G3 is direct. So you can write G3. So the conversion formula that is already dealt in module 1 is G3 is A3 itself. Then what is G2? G2 is goes like this. G2 is A3 XOR A2. Then what is G1? G1 is A2 XOR A1. And what is G0? G0 is A1 XOR A0. For example, if you are having a binary code like this, say 1 1 1 0. So the corresponding gray code is 1 will come directly. 1 XOR 1. 1 XOR 1 is 0. Then again 1 XOR 1 is 0. 1 XOR 0 is 1. So this is the corresponding gray code. So the corresponding gray code of 1110 is 1001. This is the corresponding gray code. Okay. So now we need to form a circuit for these expressions. We need to form a logic circuit for these expressions. Here it is binary to gray code converter. For binary to gray code converter, what should be the input? The inputs are the bits of the binary code. That is A3, A2, A1 and A0. That are the input bits. Now, what are the outputs? Outputs are G3, G2, G1 and G0. These are the outputs. So first of all, I am drawing inputs. Inputs are A3, A2, A1, A0. Now coming to what is G3? G3 is A3 itself. G3 is A3 itself. Now what is G2? A3 XOR A2. So G2 is A3 XOR, let's forget, A2. So that is G2. Now what is G1? G1 is A2 XOR A1. A2 is there, A2 XOR with A1. A2 XOR with A1. So that is G1. Now what is A0? A0 is A1, G0. G0 is A1 XOR A0. A1 XOR A0. So that is basically G0. Okay. So this is basically a binary to gray code converter. For example, if you are giving 1 0 1 0 as input, what is the corresponding gray code? Here we will get 1. What is G2? G2 is A3 XOR A2. 1 XOR 0, that is 1. What is G1? G1 is A2 XOR A1, that is 0 XOR 1, that is 1. Now what is G0? G0 is A1 XOR A0. 1 XOR 0, that is 1. So the corresponding gray code. So the input is 1 0 1 0, that is the BCD code. And the corresponding gray code is 1 1 1 1. That is the corresponding gray code. Okay. Now if you are giving some other example, if you are giving in say 0 1 1 0, what will be the corresponding output? G3 will be 0. What is G2? G2 will be 0 XOR 1, that is 1. Here what happens? G1 will be A2 XOR A1, that is 1 XOR 1. 1 XOR 1 is 0. Now coming into G0, G0 will be 1 XOR 0, that is 1. That means if the input is 0 1 1 0, which is a BCD code, the output will be 0 1 0 1, that is the corresponding gray code. Hope you have understood the concept of binary to gray code converter. So here I have explained a 4-bit binary to gray code converter circuit. Now coming to the next type of code converter, that is I am converting gray code to binary code converter. Okay. So next one is gray to binary code converter. Gray to binary code converter. Okay. So let the gray code input be G3, G2, G1, G0, and binary. The corresponding binary which I am having is B3, B2, B1, B0. So you need to get B3, B2, B1 and B0 in terms of G3, G2, G1 and G0. Okay. So here how the conversion is applied. You can see B3 is equal to G3 itself. And what is B2? B2 is, it goes like this. These two things are XORed. So what is B2? B2 is basically B3 XOR G2. You will get that code. Now what is B1? B1 is B2 XOR G1. This is B2 XOR G1. So that is B1. Now what is B0? B0 is B1 XOR G0. This is G1. Okay. So this is the conversion formula. Okay. Now you need to realize a logic circuit for this. So here gray code is the input. Gray code is the input and binary code is the output. So I am having input as G3, G2, G1, G0. Now what is B? So outputs are okay. B3 is equal to G3, so you can directly connect. So that is first expression. Second one is B2 is B3 XOR G2. So this B3 itself B3 XOR with G2. Okay. There you will get B2. Now what is B1? B1 is B2 XOR G1. We have an XOR gate here. Then B2 needs to be XORed, right? So here we will get B1. Now coming to B0. B0 is what? G0 XORed with B1, right? That is B0 and B1 is XORed. Okay. So here this is the gray code and this is the binary code. Now for example, if you are having the gray code as 0, 1, 1, 0, what is the corresponding binary code? B3 will be 0. What is B2? G3, it is 1 XOR 0, that is 1. Now what is B1? 1 XOR 1, that is 0. What is B0? 0 XOR 0, that is 0. Therefore, if you are having a gray code 0, 1, 1, 0, which is a gray code, then the corresponding binary code will be 0, 1, 0, 0. That is the corresponding binary code. Okay. And this circuit is known as binary to gray code converter. This is gray to binary code converter. Okay. So here I am going for this 4-bit gray to binary code converter. So coming to the recap of this lecture, we have given an introduction to code converters. What is basically a code converter? And a code converter means you are having a certain code. So for example, if you are having 8421 code or 5211 code, it needs to be converted to some other codes. Okay. So the black box or the intermittent element between these two codes is known as code converter. Now, to start with, I have done with a 4-bit binary to gray code converter. So binary to gray code means here A3, A2, A1, A0, that is a 4-bit binary, and the corresponding gray code is G3, G2, G1, G0. Now, as referred to module 1, the conversion formula is given like G3 is equal to A3, G3 is equal to A3 XOR A2, G1 is equal to A2 XOR A1, and G0 is A1 XOR A0. Okay. So I have shown an example of given a binary code, how to convert it into gray code, and the corresponding logic circuit with ambient explanation is obtained. Now coming into gray code to binary code converter, the conversion formula is dealt with, and how to convert a gray code to binary code using a logic circuit is also dealt with. Okay, so here I am going with 4-bit gray to binary code converter. Okay, so that is all for this lecture, and in the next lecture we will deal with some other type of code converters. Okay, so there we will deal with the 4-bit binary to BCD code converter and access3 code converters, etc. Okay, so thank you and meet you in the next lecture.